to this point with product or with power rule is I gave you, let's say y equals 3x squared plus 6x plus 1. Y prime, what we do for power rule, this is product rule, but we're going to go over power rule first. I'll write that here. Is we take our exponent and we drop it in front. So this 2, we could do the limit as h approaches 0 of f of x plus h minus f of x all over h, and it would give us the first derivative, correct? Or if it's a polynomial, we can just use power rule. So we take the 2, we drop it in front, we rewrite 3x, and then but this drops by 1. So the 2 becomes a 1. And then we get plus, well, this is a 1, so the 1 drops in front. And then we get 6x to the 0. What is anything to the power of 0? 1. So that x is gone. And then this x, or this number 1, has an x as well. It's just x to the 0. Okay? X to the 0 is 1. So even your constant has an x on it. We just don't write it because it's x to the 0. The 0 drops in front, and we multiply it by 1x to the negative 1. Well, what happens if we get a 0 in front? It's just gone. So anytime you have a constant term, like a 1, a 7, an 11, a 12, any of those things, they just go away. They're just gone. And anything to an x is just the number itself. So we are left with 6x plus 6. Done. And we're not having to do the limit as h approaches 0. So we'll do another power rule. What if I give you, this is number 1. What if I give you number 2? Y equals 8x cubed plus 7x squared minus 4x plus 1. So what's y prime going to equal? What do I do? Take the 3, drop it in front. What do I get? 3 times 8, what's that? 24. So do I have to show that in between step if I can go 3 times 8 is 24? No. So that number drops in front and joins it, and then it drops by 1. So it's x to the 2 plus the 2 joins the 7. What's 2 times 7? 14. X to the what? 1. What happens when it's x to the 1? It's just going to be that coefficient, right? Because it'll be x to the 0 off, so it'll go away. So it's going to be minus 4. And what happens to the constant? It just goes away. Because it's x to the 0, it's going to multiply by 0, it's going to be 9. So that's it. Can you imagine having to do this as the limit of h approaches 0? You'd have x plus h cubed plus 7x plus h squared minus 4x plus h plus 1 minus all of that all over h, expand it out, cancel terms, and you get that. It'd be kind of terrible. Okay, so we can use power rule whenever we have a variable base to a numerical exponent. One variable base to a numerical exponent. So what if I do this? Y equals 7x to the negative 2 plus 3x minus 5x to the negative 4. Can I still do power rule? Numerical base to variable exponent. Variable base to numerical exponent. Yes. I take what's on my exponent, I drop it in front and multiply it, drop it by 1. Every time. So here I'm going to get y equals negative 2 times 7 is negative 14, x to the negative 3. You have to take 1 off of it. Has to get smaller, not larger. What happens when I have 3x? You get plus 3, because this can drop to x to the 0. And then negative 5 times negative 4 is positive 20, x to the negative 5. Yeah? Okay? All right. What if I give you this? Y equals 7 over x to the 5 plus 3 over x to the 2 minus 4 over x plus 6. Is that a numerical base, or sorry, a variable base to numerical exponent currently? No, but are those all monomials on the bottom? Monomials being one term. Each one has a monomial, yeah. Can I, using grade 10 exponent laws, move them up? What do they become? Negative. So I'm going to rewrite this before, and I don't put y prime. Some people put y prime and they just move those up. You haven't done the derivative at all. You're rewriting it in a different way. Okay, so it's still y equals 7x to the negative 5 plus 3x to the negative 2 minus 4x to the negative 1 plus 6. So I don't have y prime at all, right? I just have y equals. Do you agree? All I did was rearrange those x's. I didn't do the derivative at all. Can I now do power rule? Yes. So I get y prime equals negative 5 times 7, negative 35x to the negative 6, negative 2 times 3, negative 6, x to the negative 3, negative 1 and negative 4 is 4, x to the negative 2, what happens with the 6? Bye-bye, right? Constant, so go bye-bye. And this could be the answer, or they might write the answer as negative 35 over x to the 6 minus 6 over x to the 3 plus 4 over x to the 2. Just moving them back down and making them positive, right? That's all I did. So only the exponent moves to the bottom and becomes positive. The numbers stay at the top. They're not affected by that. It just depends on the answer. Yeah. If it was just an answer from you, it wouldn't matter. Same thing.
Miss Lepp, is that minus 6 over x to the 5 or x to the 3?
It's a 3. It's not a 5. A 5 would be this way. It's like this. It's a 3. We'd have to go that way to have a 5. A 3. I don't know how to make it a 3. I think you guys maybe might want to sit front row like at church here. There's no one. All by myself, I think. All right. 5. One last one. Y equals 3 square root x squared minus 4 cube root x5 plus 6 square root x. In this current form, these do not screen power rule. But once again, we got to go back to grade 10, just like we did in the previous one. We made those variables in the bottom up. These we have to convert them to rational exponents. Okay? So, we're going to have y equals 3. Trick question, what is this one actually? Square root of x squared. Just x. Minus 4. Now, you drop the 3 underneath, right? So it's going to be x to the 5/3 plus 6. This has a 1. This is an index of 2. So it's 6 to the 1/2 x 1/2, sorry. It's getting worse. Okay. So now we get to do fractions, which everyone loves so much. So what is the derivative of 3x? 3. Make sure you put y prime. So you know you found the derivative of the tangent slope, right? Then we're going to get minus 5/3 times 4 over 1. X to the what? What's 5/3 minus 1? 5 over 3 minus 3 over 3 is 2 over 3. And then plus 1/2 times 6. X. What's 1/2 minus 1? Negative 1/2. So we get y prime equals 3 minus 20 over 3x, which we could write as the cube root of x squared, proving a point. And this would be 6 over 2, so plus 3 over root x. Because you'd move x to the half to the denominator, right? You'd move your x to the half to the denominator, and then it would be root x. Once again, I repeat. Yeah. Options. 20 over 3 cube root of x squared plus 3 over root x. All right. So this isn't on your unit exam, right? This is the next unit called derivatives. So everything up to yesterday was on the unit exam. Anything? So if I ask you to find a derivative on the unit exam, though, and I give you x squared plus 3x plus 6, you can't tell me it's 2x plus 3 and be done. Because I'm going to say determine the limit using first principles, which is the limit formula. So keep that in mind. All right. So now we're going to do power rule. Product rule. So product rule happens when you have the product of two things. Product is multiplication, correct? So if you have FG and you want to find the prime of it, so FG beside each other is the same as saying F times G. Two things multiplied, correct? How we do the formula is F times G prime plus G times F prime. It sounds way worse than it is. But you have to use the product rule whenever you have two things producted. I use the word producted. It's not even a real thing. Yeah. Yeah. All right. That's why a lot of the work is in written response, so that you have to show your work. You can't just use your calculators. All right. Determine y prime. 1. Y equals 2x plus 1 times 3x minus 4. Now, some people may say, can I not just expand that and do power rule? Yep. We're also going to show that you can do product rule, because it's not going to stay nice and just polynomials all the time. We're going to have trig, or chain rule, or exponents. So we're going to go through the basic stuff first. So the first way we're going to do this one is power rule. So I can't do power rule currently the way it is. So what am I going to have to do first? Expand it. Get it into a form that I can do the power rule in. So I'm going to go y equals 6x minus 8x plus 3x minus 4. Collect like terms. That should be 6x squared. Oops. 6x squared minus 5x minus 4. Do we agree? Now some people box it and move on. Have you found the derivative at all? So no, don't move on. Y prime equals what? 2 times 6, which is 12, x to the 1 minus 5. So that's using power rule. And sometimes power rule is faster. The next one we're going to do is product rule. It's treating them like they are two things multiplied, taking the product of them. So we have y equals 2x plus 1 times 3x minus 4. F, G. Could I label them G and then F when it's product? Does this matter to this? This matter to this? 2 times 3 is the same as 3 times 2. So technically it doesn't matter. I just chose to put the first ones out. Now in order to use the formula, I need fg prime plus gf prime. I have f and g, so I still need the derivative of f and the derivative of g, correct? So over here I'm going to write that. F prime is what? What's the derivative of 2x plus 1? 2. G prime is what? What's the derivative of 3x minus 4? 3. And now I just use my formula. So y prime equals f, which is 2x plus 1, times g prime, which is 3, plus g, which is 3x minus 4, times f prime, which is 2. And then I expand them and collect like terms. So this one you start the derivative right away. This one you have to expand and then do the derivative in the very last step, right? Sometimes you don't get a choice. It has to be product rule because you can't do power rule. So we're going to get 6x plus 3. So if you're like, I'm never doing product rule, well, that ain't true. 6x minus 8. 12x minus 9. Well, I do some with radicals, which makes it a bit harder, but we'll do one nice one again, and then we'll do the radical one.
Yeah.
Does everyone have that? 2. Y equals 3x cubed plus 4 times 1 minus 2x cubed. Go. Okay, we have F, we have G. F prime is going to be 27. I do that every time. My goodness. 9 x squared. And G prime is going to be negative 6x squared. So Y prime equals F G prime plus G F prime. Distribute, distribute. So I get negative 18. What do I do with my exponents when I have two bases that are the same? It's like 3x cubed minus 6x squared. Negative 18x what? 5, you add them. Minus 24x squared. Plus 1 times 9x squared is 9x squared. Minus 18x5. So y prime equals negative 36 x5 minus 15 x squared. Sometimes in the book or on a test, they might take your answer at the end and GCF out things if they can. So in this one, we could take out a negative 3x squared and be left with 12x cubed minus 5. And the reason why they do that is for the next unit when we have to find critical numbers. We have to find the critical numbers because where the first derivative equals 0 or where max and mins are located, right? So if you can take out a GCF, you do. That is a plus 5, Ashton. I have no idea what you're talking about. Super wide. But that is clearly a 5 compared to what you thought was right. Okay, we're trying this one. Three. G of x equals x minus x squared, and then 2x minus x to the 4/3. Go. So we have f, g, f prime is 1 minus 2x, and g prime is 2 minus 4/3 x to the 1/3. All right. Because remember, you do 4/3 minus 3/3, which is 1/3, right? Okay. So g prime of x is f times g prime plus g times f prime. So let's math. Okay. X times 2 is 2x. X times 4/3 x to 1/3 is negative 4/3. And remember, we add exponents. So this is an x to the 1 and 1/3. So it would be like 3/3 plus 1/3. See if they common denominator, right? So 3/3 plus 1/3 is 4/3. Negative x squared times 2 is negative 2x squared. And then we're doing minus 1 times negative 4/3 is positive 4/3. And then I'll do this over here. What is x squared times x to the 3rd? Well, we can't put them together except for by addition, correct? And the only way we can add fractions is common denominators. So I need to turn this 2 into an over 3. So it's going to be 6/3 times x to the 1/3, which is x to the 7/3. Plus. Now we're getting to the next set of brackets. 2x times 1 is 2x. 2x times negative 2x is negative 4x squared. Negative x 4/3 times 1 is negative x to the 4/3. And then negative x to the 4/3 times negative 2x is positive 2. Now we're doing x to the 4/3 times x to the what? Well, we can't put them together unless we have common denominators. So we get x to the 4/3 times x to the 3/3 equals x to the 7. And then you have to put like terms together. Okay. So we're going to get 2x plus 2x is 4x. Negative 2x squared minus 4x squared is negative 6x squared. And then we have negative 4/3 x to the 4/3. Negative 1x to the 4/3. I'm going to write that over here. Negative 4/3 x to the 4/3 minus 1x to the 4/3. Put them together by subtraction. See if the common denominators. Negative 4/3 x to the 4/3 minus 3/3 x to the 4/3 equals negative 7/3 x to the 4/3. And then our last one is 4/3 x to the 7/3 and 2x to the 7/3. So 4/3 x to the 7/3 plus 2x to the 7/3. 2 can turn to a what over 3? 6 over 3. So I'm going to get 10 over 3. I'm giving you 4 for practice today. So here are your 4. Yes, they're homework. But we're going through them tomorrow.
So, wait, there's no for tomorrow?
Yeah, it's 4 questions. If you work right now, Kelsey, I bet you can get through half of them. This is what happens when I lower your standards. I need to give you guys like 27 questions a day. So then when I give you 4, you're like, wow, this is amazing.
Thank you for only giving us 4.
There we go. There we go.